Hey students, in this video we're going to go through the answers for the Cumulative Practice Chapter 6. So number 1, you buy roses at a flower shop for $3 each. How many roses can you buy with $27? Well, if I divide $27 by $3 per rose, I would get 9 roses. I can buy 9 roses. Number 2, you are making identical fruit baskets using 16 apples, 24 pears, and 32 bananas. What is the greatest number of baskets you can make using all of the fruit? So this is just a different way to find the GCF. They're asking for the greatest common factor, the largest number that fits evenly into each of these. So what I'm going to do is I'm just going to actually test them. For example, I'm going to pick the greatest amount and I'm going to see, can this fit evenly into each of these? Is it a factor of each of these? Because if it is, it would be the greatest of my options, the greatest common factor. So 16 can be split evenly into 16. I could have 1 apple per basket. But when I try to do this, 24 divided by 16, that's not going to fit evenly. I can't evenly divide my 24 pears among that many baskets, so it's not going to be option I. Let's choose the next greatest option. So 16 apples split evenly among 8 baskets. That would be 2 apples per basket. And then we'll try 24. 24 divided by 8. So 24 pears split evenly into 8 baskets. That is 3 pears per basket. And finally, 32 bananas split evenly into 8 baskets. That would be 4 bananas per basket. So it looks like this is their greatest common factor. It's the largest number that fits evenly into all 3 of these numbers. Another method you could have used is to list the factor pairs of each. I would choose the largest number first, so 32. 1 times 32, 2 times 16. Can't use 3. 4 times 8. Can't use 5. Can't use 6. Can't use 7, and 8's a repeat. So here is my list of factors for 32, and I would want the greatest one that all 3 have in common. So I would look at my next number, so 1 times 24, 2 times 12, 3 times 8, 4 times 6. 5 doesn't work, and 6 a repeat. So far the greatest amount these 2 have in common is 8, but we'll just want to check in with our last one and see if 8 is truly the greatest thing they all have in common. 1 times 16, 2 times 8. Can't use 3. 4 times 4. 4 is a repeat, so I'm done, and it looks like, yes, 8 is the greatest thing that they have in common. It's their greatest common factors. There's 2 different methods for solving this for GCF, greatest common factor. Number 3, which equation represents the word sentence? It says the sum of 18 and 5. Sum means addition, so it's not A or D. The sum of 18 and 5 is equal to 9 less than a number y. So less than does mean subtraction, but when I say 9 less than y, that means I'm taking the 9 away from the y. It should say y minus 9, not the other way around. Less than is subtraction, but you need to switch them. So 9 less than y means y minus 9. Number 4, the tape diagram shows the ratio of tickets sold by you and your friend. How many more tickets did you sell than your friend? So this does not mean that you sold 3 more tickets than your friend. You have 3 more boxes than them, but look, there's 42 total tickets, so there's not just 1 in each of them. So if there's 42 tickets total among you and your friend, those are split evenly into 7 boxes. That means there should be 6 tickets in each box. Now, I want how many more you sold than your friend. You sold 3 boxes more, but there's 6 in each of them. So 6, 12, 18 more. You sold 18 more tickets. 3 boxes, but 18 more. Number 5, what is the value of x that makes the equation true? So I'm going to go ahead and write my equation down and draw my line through my equal sign. I want x by itself. So to undo plus 59, I'm going to subtract 59. To make x be all by itself. And whatever I do to one side, I have to do to the other. So let's make sure we line those up when we go to subtract. Don't want to do 2 minus 9, so I borrow from the 1, making it a 0. This becomes a 12. 12 minus 9 is 3. Don't want to do 0 minus 5, so borrow from this one, making it a 0. And this becomes a 10. 10 minus 5 is 5. So I got 53. X equals 53. And all it wants me to type in is the value of X. So we're going to just type in 53 there. Number 6. The steps your friend took to divide two mixed numbers are shown. So they had 3 3/5 divided by 1 1/2. Looks like first they changed them both into improper fractions. So 3 times 5 was 15, plus 3 was 18. That's where they got 18/5. And then they did 1 times 2 is 2, plus 1 is 3. So they got 3/2. They multiplied across and then made it back into a mixed number. So I want to know, what should your friend change in order to divide the two mixed numbers correctly? Well, if you notice, they immediately changed this to multiplication, but they did not flip the second fraction. 1 1/2 is 3/2. It should have been 2/3. They should have flipped it. When you flip a fraction, that's called the reciprocal. So instead, they should have multiplied by the reciprocal of 3/2. They should have changed it to 2/3. Number 7, a company ordering parts receives a charge of $25 for shipping and handling plus $20 per part, right? Which equation represents the cost, C, in dollars of ordering parts? So I'm probably going to set this up as what the cost equals, that the cost equals a certain amount. I know the cost should be $25 plus $20 per part, $20 times P. So that's going to be option F. The cost equals my shipping amount plus $20 per part, $20 times the number of parts. Number 8, which property is illustrated by the statement? So it looks like they went from 5 times this group, A plus 6, to 5 times A plus 5 times 6. This is where you have a number multiplied by a group, so you multiply it by each piece of the group, and that is called the distributive property. Number 9, what is the value of the expression 46.8 divided by 0.156? So I'm going to set this up as long division. First number inside the box, second number outside. Remember, when there's a decimal on the side, you want to slide it. I want to turn this into a whole number. So I'm going to slide it 3 times. That gives me the number 156. And however many times I slid this one, this is a mirror, I need to slide this one the same amount. 1, 2, 3. So I have to insert 2 zeros. 46,800. And now I'm ready to divide. So 156 doesn't fit into 4 or 46. It will fit into 468. So 156 plus 156, that's 312. If I add another one, so 312 plus another 156, what are we going to get? 864, 468 exactly. So 3 of them fit. Those 3 156s, 3 times 156 is 468 exactly. And when I subtract, I get 0. Now the next two things I'm going to bring down are both going to be zeros. So I'm not going to be able to put 156 into them. But don't forget to fill in the empty spots with zeros. So I get 0, 0, 3, 0, 0, which is just the number 300. Number 10, in the mural below, the squares that are painted red are marked with the letter R. What percent of the mural is painted red? Well, first, let's write a fraction of how much is painted red out of the whole thing. So I'm going to count how many total boxes there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. There's 20 across the top. And then there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 this way. If I multiply 20 by 10, because I have 10 rows of 20, I'll figure out how many total squares there are. 2 times 1 is 2 with 2 zeros on the end. So there's 200 boxes in all. Let's count how many are red. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then another 9 is 18. Another 9 is 27. Another 9 is 36. 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48. So 48 out of 200 are painted red. I want to make this a percent, so it should be out of 100. So I'm going to divide this by 2 to make it 100. And then I do the same to the top. 48 divided by 2 is 24. So 24% of them are painted red. Number 11, which expression is equivalent to 28x plus 70? Well, remember when a number is multiplied by a group, you need to multiply it by each part of the group. So I'm going to start by multiplying 14 by 2x and by 5. So 14 times 2x, 14 times 2 is 28. I put an x on the end, 28x. And then 14 times 5 is 70. Look at that. I already got my answer. It is option A. I'm just going to show you one more to show why it doesn't work. I would multiply 14 by 5x and by 2. So 14 times 5 is 70. So 14 times 5x is 70x. And then 14 times 2 is 28. So this one would kind of be backwards or opposite. This one here, if I multiply 2 by each part, 2 times 14x is 28x. But 2 times 5 is only 10. So the second number doesn't match. And then this last one here, this only has an x term. There's not even going to be a whole number. 14 times 7x, that's going to be 98x. We don't even have a whole number there at all. And so this is the one that is correct, option A. And finally, 12. What is the first step in evaluating the expression? If I use GEMDAS, the very first step is what's in grouping symbols. So that's to add 5 and 2.